Hello students, today we will see the SR latch. Yes, the simplest type of flip-flop. It's a SR latch. So it's a very simplest which is not having the clock. So that's why this is a latch. This can be denoted as yes, or I can say that right R. These are the inputs and Q and Q bar are the outputs. So this is the symbol of SR latch. This SR latch can be constructed using two cross coupled NOR latches, or I can say that NOR gates. Sorry. So using two NOR gate, active high SR latch can be constructed. So we'll see the circuit of SR latch using NOR gates. So this is one NOR gate and this is another NOR gate. So this is R, this is S. So this is Q, this is Q bar. So this is the circuit diagram of the SR latch using NOR gate. So this is first gate G1 and this is G2. Now when we go for the working of this particular SR latch, let us assume that initially it is set. It is set means initially Q is equal to 1. Initially Q is equal to 1 and Q bar is equal to 0. Okay. So when first if S is equal to 0 and R is equal to 0, then as S and R both are 0, Q is 1 and Q bar is 0 initially. We have assumed it. Okay. So if I go for Q1 here and Q bar as a 0, then in that case, if I say R and S to be as a 0, 0. Okay. Then input to the G1 is 0, 0. Q will be remaining 1. Okay. So input to G1 is 0, 0. So output is Q is 1. Okay. While for G2, input to G2 is here Q is 1, 1 and 0, 1 and 0. So 1 and 0, it's a 0. So here the output level of Q bar is also 0. Okay. So when we go for S is equal to input to the G2 is S is 0 and 1 from Q. Okay. Then output is 0. So obviously initially here Thus, when S is equal to 0, R is equal to 0, there is no change in state. Okay. So, if we go for S and R, no change in output state. Okay. Now, next is here, if Q is equal to 0, initially Q is equal to 0 and Q bar is equal to 1. And if S is equal to 0, R is equal to 0, then input to G2 is 0 and 0. Okay. So output is Q is remaining 1. So Q bar is 1. Okay. While input to G1 is R is equal to 0 and Q bar is, we have taken at the starting, 1. Okay. So here the output Q remains 0. It implies that when S is equal to 0, R is equal to 0, the latch remains in same state. Okay. Now for the next consideration, if initially this is A part, when we are considering S is equal to 0 and R is equal to 0. Now this is B part. If I suppose initially, if I assume Q is equal to 1 and Q bar is equal to 0, and if S is equal to 1 and R is equal to 0, then input to G2 is, if we go for input to G2, if we see the diagram, Q is equal to 1, Q bar is equal to 0, but now the S is equal to 1 and R is equal to 0. So for G2, here both inputs are 1 and 1. Okay. So output here of G2, which is Q bar, output Q2, which is Q bar, remains 0. Okay. While the input to G1, now we'll see input to G1. Input to G1, yes, Q bar is 0, we have said it at the starting, and R is also equal to 0. So R 0 and Q bar are 0. So here both are 0, 0, and obviously we are getting Q to be as a 1. So here input to G1 are 0 and 0. Okay. So the output Q goes to 1. So if we see this, that is, if S is equal to 1, R is equal to 0, the output is becoming 1 while inverted output is becoming 0. Also, we can try for another combination, that is, if Q is equal to 0 and Q bar is equal to 1, then at the same time, what are the conditions? That is, S is equal to 1 and R is equal to 0. Okay. So in this case, if I say input to G1, first of all, we will see if Q is equal to 0 and Q bar is equal to 1, and if S is equal to 1, R is equal to 0. So the input to G2 is first, S is 1. So obviously here, Q is equal to 0. So this is for G2, this is 0, and S is equal to 1. So input to G2 is 1 and yes, input to G2 is 1 and 0. So output goes to Q bar goes to 0. Okay. So here second thing, that Q bar is equal to 0. Similarly, in this case, input to G1 is, now input to G1 is here. In this case, if we consider Q is equal to 0 and Q bar is equal to 1, then and S is equal to 1 and R is equal to 0, then for G1 this is 1 input and this is R is equal to 0. So here for Q1 also, here we can go for 1 and 0. So input to G1 is 0 and 0. Okay. So here we will get the output to be as Q is equal to 1, or I can say that Q is equal to 1. It means that here when we go for the S is equal to 1 and R is equal to 0, in that case the SR latch goes to the set state. Okay, so if I consider this both, then SR latch goes to the set state. Okay, now for the third case, if we go for the third case, if Q is equal to if Q is equal to 1 and Q bar is equal to 0. Okay, and if I say this is C condition, S is equal to 0, R is equal to 1, I can draw again here diagram so that you will be reference this circuit. This is R, this is S. Okay. Now if I say Q is equal to 1, Q bar is equal to 0 and S is equal to 0, R is equal to 1. So this is G1 and this is G2. So input to G1 is, yes, input to G1 is R1 and 0, 1 and 0. Okay. While the output of G1 becomes Q is equal to 0. Okay. Q is equal to 0. Input to G2 is, yes, input to G2 is 0 and here 1. So input to G2 is 0 and 1. Okay, sorry. G2, yes, Q is equal to 1. So Q goes to 0, and as Q goes to 0, it's 0 and 0, sorry. Then output of this is G2 is Q bar is equal to becoming to be as a 1. Okay, it means that if I say that Here, when I apply the S is equal to 0 and R is equal to 1, Q becomes 0 and Q bar becomes 1. Okay, it means that here the flip flop goes into reset state. Okay, now if last condition is if S is equal to 1, R is equal to 1, then both corresponding outputs Q is also equal to 0 and Q bar is also equal to 0, which is invalid. So this is the operation of SR latch using NOR gate. So if I go for the truth table of this particular NOR latch, then I have to write the states like this. These are inputs and this is output. Okay, inputs are S, R and output is Q. Okay, so at the starting, if S and R are 0, then Q is remaining as previous, that is Q0. It means that no change in a previous state. Okay, if I go for S is equal to 0 and R is equal to 1, then Q output is 0. It means that this is a reset state. Okay, and if S is equal to 1, R is equal to 0, Q is equal to 1, so this is set state. While S and R are both are 1 1, then there is a invalid condition, so this is not no allowed state. Okay, so this is the truth table of the SR latch by using the NOR gate. So when I consider this NOR latch, I have to go for the operation like this. Thank you.